Hey everyone, and welcome. Have you ever really thought about the secret life of a raindrop? Today, we're going to go on this absolutely incredible adventure, following a single drop of water on its epic planet-wide journey. It's a trip it's been taking for billions of years, and it's happening all around us right now. So, let's dive in.
You know the feeling, right? You see a big puddle after a storm, you go inside for a few hours, come back out, and it's just gone. I mean, where does it go? Does it just soak into the ground? Does it vanish into thin air? Well, the answer to that simple question is the key to understanding one of the most important processes on our entire planet.
The secret is the water didn't disappear at all, it just changed its address. It's all part of what we call the water cycle. Think of it like a giant planet-sized recycling system that never ever stops. It's this continuous loop where water moves from the ground to the sky and back again. And the whole thing is powered by the amazing energy of the sun.
Okay, but to really get how this whole massive journey works, we've got to shrink down. I mean, way, way down. We need to take a peek into the secret world of the tiny particles that make up water itself. So here's the deal. Everything, you, me, this planet, it's all made of these super tiny things called molecules. And water, of course, is no exception. These are the basic building blocks, and how they act, how they're arranged, and how much they're zipping around is what decides if water is going to be solid ice, liquid water, or an invisible gas. All right, first up, let's talk about water's most rigid state, the one we all know from our freezers, ice. So when water is frozen solid, its molecules are super organized. They're locked into this beautiful crystal-like pattern called a lattice. You can almost picture them like little soldiers standing perfectly in formation. Now, they're not completely still. They're kind of vibrating in place, but they hold that rigid shape. And that's what makes ice, well, ice. And you know what? This super organized structure is the reason for one of water's weirdest and most important quirks. It's kind of weird, right? But that crystal pattern actually creates a little bit of extra space between the molecules. And because of that extra space, ice is actually less dense than liquid water. So what does that mean in the real world? It means ice floats. It's the whole reason why icebergs drift in the ocean and why lakes freeze from the top down, which is super important for protecting all the fish and life underneath during the winter. Okay, so let's warm things up a bit and move on to the state of water we see every single day. Now, in liquid water, those little molecular soldiers have broken rank. They're more like people milling about in a crowded room. They're still packed pretty close together, but now they can slide and slip right past each other. And that is why liquid water can flow and take the shape of any container you pour it into. And what happens if we crank up the heat even more? Well, that's when we get to water's invisible state, gas. Or as we usually call it, water vapor. As a gas, these water molecules are just buzzing with energy. Forget the crowded room. Now they're like dancers who have the entire ballroom all to themselves. They're moving super fast, they're really far apart, and they'll just expand to fill whatever space they're in. And this stuff, this water vapor, it's all around us, in the air, right now, even though we can't see it.
So, okay, we've got solid, liquid, gas, 3 different states. But what's the magic trick that lets water jump between them? Well, it's actually pretty simple. It all comes down to one thing: energy, usually in the form of heat. It's actually a pretty straightforward relationship. You add heat, you're giving those molecules a shot of energy. They start to dance faster and faster, break their connections, and spread out. That's what gives us melting and evaporation. On the flip side, if you cool things down, you're taking that energy away. The molecules slow down, they start huddling closer together, and that's when you get condensation and freezing. Aha! And this brings us right back to our mystery puddle. When the sun beats down on it, its heat gives those top layer water molecules enough energy to just break free and escape into the air as water vapor. That's evaporation. So the puddle didn't just vanish, it literally flew away, one molecule at a time. All right, so let's talk about the reverse. You've totally seen this happen, right? You get a nice ice-cold glass of water on a hot day and the outside of the glass gets all wet. That's condensation. All that invisible water vapor that's in the air touches the cold surface of your glass. It instantly loses its energy and it turns right back into little liquid droplets. But wait a second. Is it a fair question to ask, is the glass just leaking? I mean, it really does look like the glass is sweating.
how do we know for sure that water is just appearing out of thin air and not just seeping through the glass? Well, turns out there's a super simple experiment to prove it. And this is something you can totally try at home. Grab a glass, fill it up with some ice and water, and then here's the key. Add a few drops of something with color, like food coloring or red ink. Let it sit for a few minutes until you see those droplets form on the outside. Then, just take a napkin and wipe the outside of the glass. And now for the big reveal. The napkin is going to be wet for sure, but it's not red. Think about that for a second. If the glass was leaking, that red, inky water would have come through, right? But since the water on the napkin is clear, it's absolute proof that it had to come from the air around the glass. Pretty cool, huh? That's condensation. Proven.
Okay, so now we get the secret dance of the molecules. We understand how water changes its state. So let's zoom back out and see how this tiny, invisible dance powers the entire water cycle for the whole planet.
So, step 1, evaporation. It all kicks off with the sun. Its powerful energy heats up the huge surfaces of our oceans, lakes, and rivers, turning that liquid water into invisible water vapor that starts rising up into the atmosphere. And hey, it's not just from big bodies of water. Even plants get in on the action, releasing water vapor from their leaves in a process called transpiration.
Okay, step 2, condensation. So as all of this warm, moist air rises higher and higher, what happens? It gets colder. And just like with our cold glass of water, that cooling makes the water vapor lose its energy and turn back into teeny tiny liquid droplets. These little droplets then grab onto microscopic dust particles that are just floating around up there. And when billions and billions of them get together, poof, you get a cloud.
And that brings us to the final step, precipitation. Up in the clouds, those little water droplets start bumping into each other, merging and growing bigger and heavier. Eventually, they get so heavy that they can't stay floating in the air anymore, and they fall back down to Earth. We call that precipitation. You know it as rain, snow, or hail. That water then fills up our rivers and oceans, soaks into the ground, and guess what? The whole amazing cycle is ready to start all over again.
So get this, the water we have on Earth today, it's ancient. It's the same water that's been here for billions of years, just getting recycled over and over. That glass of water you're about to drink, those exact same molecules could have been in a storm over the Pacific Ocean last year. They could have flowed down the Amazon River 1,000 years ago. They could have even been inside a dinosaur millions of years ago. It's all the same water on an endless, epic journey. And it just makes you wonder, right? Where will it go next?